Well, good morning, everybody, and welcome to the first of today's webinars from Smart Vision Europe. Today, in this first webinar, we're looking at working with SPSS Statistics. My name is Jarlath Quinn. I'll be joined online today by my colleague Rachel, and Rachel will be making sure that everybody's logged in correctly as we're going along. If you haven't joined in these sessions before, you should be aware that these sessions are recorded, so you'll be able to listen to them again afterwards. There is some slideware here that we're going to be using. Most of it's to demonstration, but we'll email out a link to you after the session is ended so that you can download those materials. And if you think it's particularly relevant for colleagues who are unable to join us at this point in time, it may be possible for us to arrange a rerun of it, perhaps on a private basis. The best thing to do is just to send us an email or something like that, reach out to us and and we'll see what we can do. With regard to asking questions, all the lines are muted. So we ask you to use the chat panel and we'll follow up with you afterwards, normally speaking. My colleague Rachel, as Zay is online, she'll be checking that chat panel as we're going along, and she'll be able to field a lot of the questions anyway. Okay, so we're going to be talking today about IBM SPSS Statistics, and we're able to do that because we're actually a gold accredited partner to IBM. We're also a partner to Predictive Solutions, a company called Predictive Solutions, and Data Robot. And as an organization, Smart Vision specializes in advanced analytics, big data technologies, AI, statistics, all that kind of stuff, data science. Though it has to be said, we do work with other technologies, including open source technologies such as R and Python. We're a relatively small organization, but we're made up of a team of veterans of the analytical software industry. I've probably worked in that industry for about 30 years. The common denominator is that we've all worked for SPSS Incorporated at some point. So we were all senior members of the SPSS team in technical and managerial roles. So we're really very experienced when it comes to talking about these types of technologies and about how they are applied as applications across many different sectors, from public sector and private sector. So basically, SPSS Statistics is one of our sort of bread and butter products that we've been dealing with for decades. I think I first started using the product in about 1987. So it's quite, we've got quite a long history with it. So our agenda today for this particular session is to provide an overview of SPSS Statistics. First of all, give you a bit of background, and then we're going to move into getting data into the system from third-party sources, such as databases or spreadsheets. We're going to be looking at how SPSS wants us to format the data, how to set it up correctly. And then we're going to be looking at manipulating the data, so how we can create new fields, banded fields, how we can filter the data. We're going to touch on one of the modules that SPSS uses, because the SPSS custom tables module helps us create publication quality reports. And also we're going to touch upon finding statistically significant differences in groups. You should be aware that if this is something that is of interest to you, we've actually got another webinar afterwards later today, really focusing on significance testing and trying to go into the nitty-gritty of exactly how you interpret significance tests and the thinking and the rationale behind them. And we'll be looking at that in more detail. Okay, so first of all, an overview of IBM SPSS Statistics. First thing is that this software package has been around since 1968, which makes it one of the world's most popular data analysis and certainly longest running statistical interrogation platforms, and it's used for a very wide range of applications. It's very difficult to talk about a typical SPSS user these days, in the same way it's difficult to talk about a typical spreadsheet user or a typical Excel user. But suffice to say, some of these people are working in research, like healthcare research, some working in the survey research and market research, some are working in business and applications like fintech. They're modeling things like credit risk or forecasting, or even things in manufacturing applications. We're looking at asset management of machines. All of these are typical if you want to use that term in inverted commas, applications in areas where SPSS statistics might be deployed. So in the basic version of SPSS, what we call the base software, there's actually quite a lot of different statistical, analytical routines and data manipulation routines. So the things that you'd expect to see in there are things like um, statistical tests, crosstabs, the full range of different data manipulation capabilities, the full range of different graphical capabilities, as well as predictive modeling like linear regression and multivariate techniques such as factor analysis and cluster analysis, if you're familiar with those. Now, it's actually part of a family. SPSS base is surrounded by a family of potentially add-on modules. These are elements that can be added to it, and they simply reflect the fact that people use the software for different purposes. These days, IBM tends to create bundled versions of SPSS. So you get SPSS base or SPSS basic, which is usually base with a couple of modules, and then you have professional, and then you'll have other versions, expert versions, where they bundle them all together. But suffice to say that you can't choose them individually if you so wish. You may well find that you've actually already got a number of modules with your copy of SPSS if you already purchased it. You should be aware that when these modules appear, they're actually pretty seamlessly integrated. You wouldn't necessarily know you've got them until you check. But an example would be the decision trees module. It's a very popular module, and it would simply appear as an extra dialogue, an extra menu item within the analyze menu. And decision trees are very powerful because they're used to build predictive models and create profiles and find key segments. And they're very popular because, they're kind of modeling without tiers. It represents models very visually. They're pretty easy to understand. And as a result of that, they tend to be very widely used across many different applications. Here's an example of a decision tree that looks, for example, at survival on the Titanic. Here we have it. It finds the key factors that drive survival on the Titanic. Here it's finding the factor sex or gender be the primary thing which drives it. Here it is. It's running a statistical test. It splits the data by male and female and finds subgroups within that data until we find that, for males, the variable age is important, adult or child, but for the female branch, this is not important, so it's not included in it. It's very, it's a very, very flexible, very useful method that is used to try to understand what drives a key outcome, for example, or how to predict a particular outcome. Now, if you wanted more information on all these different techniques that we have and all these different modules that we have, you can simply go onto our website, and you'll find that we've got these 2 to 3 minute overviews, just little videos that just give you really short overviews of what all the different modules do. So it's well worth looking at if you're interested in that. Okay, before we get into demonstrating SPSS, the thing we have to bear in mind is that with technologies like SPSS Statistics, not just SPSS, it could be Stata, it could be, could be SAS, could be S+, whatever statistical tool you're using, could be R. You find that if you want to be good at these and be capable at working with these different applications, is you have to kind of concentrate your skills in 3 areas. You have to be able to read data in, and you need to be able to format it and manipulate it. You need to be able to transform it. And finally, you need to be able to analyze and deploy it. And so when we do an introductory course, we make sure that we hit all of these 3 waypoints, make sure that people have some experience of analyzing it, but also know how to manipulate the data and how to get the best out of it and how to format it correctly so that they can work with the data effectively. And that's one of the first hurdles that people face. So with that in mind, let's take a closer look. I'm just going to skip out to a copy of SPSS I've got here in the background. This is SPSS version 29. It's the latest version. If you've got different versions, you won't actually notice much difference between one version and the next. They tend to be pretty subtle, usually pretty small changes from one version to the next. But it looks like a spreadsheet. It's not a spreadsheet. You mustn't think of it like that. It's simply a data editor. You can have multiple data editors open at one time. I try to have only one open at one time. Otherwise, it gets confusing. And if I go to open up a file, I'm going to actually import a file here. I'm going to import a non-SPSS file type. And I'm going to go to File. Instead of going to Open Data, I'm going to Import Data and go to Excel. It turns out there's an Excel file here, which is a workbook. You can see it's XLSX. I'm going to open that. And it detects it's an Excel file. It gives me a little preview of the file. So I can see the field names across the top. It assumes the field names are in the first row of data. I've got these controls here. If there's any hidden spaces at the end of a string description or before a string description, it'll trim those because it could affect things. But most of this is actually numeric data. If I click OK at that point, you can see it goes and reads the data. And this is what the raw data looks like. And this raw data is fine. You can work with it. In fact, you'll see that if I right click on one of these fields here, like gender, and right click on it and just do descriptive statistics, what happens is it actually gives me the result in a separate window. So SPSS punches out its results in a separate window called an output viewer. And we skip back and forth between the data window and the output window. That's generally how we work with this. But you can see here it just says gender F&M. It's not a very verbose way of describing that particular field. So I might want to format that field. If I double click on it, you can see here I'm invited here to attach a label to this. So I could say, sex off employee. This is a very famous data set that comes from the 1980s. And it recorded information about employees in a bank in Chicago, and it was used as part of a court case where the bank was being sued for discrimination. It was part of an equal opportunities court case, effectively. Now you remember here it said F and M for male and female, so I could click here and say, well, actually, I'm going to give you a bit better for a description of what these are. I'm going to say F is for female and M is for male. So having attached what I call a variable label, because variables are fields, I'm now going to attach value labels, values being the coded values which represent data. And now if I right click again and say, give me descriptive statistics, you see it gives me another table down here. But now it says, instead of F and M, it says female and male. So that's a really simple example of how we might format the data. And it's also an example of why it's important to format the data, because if I look at this field here, job cut, and do descriptive statistics, you can see it's just got codes 1, 2, and 3. And the title job cut, we don't know what 1, 2, and 3 refer to. So typically we want to give these codes some labels, these values some labels, and attach value labels to them. In the same sense, though, you could have situations where you have perhaps an unusual value like 9. Okay, so a value there like 9. And you can see it suddenly sticks out. Now we've got a category 9 that's appearing in the frequency here, 9. One occurrence of this character. What is that? Well, it could be that is actually known as a missing value. It could indicate that we don't know what that person's code is. And I could say, oh, when you see a 9, treat it as missing. I'm going to give this a label. I'm going to call it job category. You can see I'm attaching to it. Now when I run it, it identifies 9 as missing, and therefore there's a slight difference, a tiny difference between the percent column and the valid percent column. The valid percent column here is saying of the valid values, 76% were category 1, 5.7% were category 2, and 17.5% were category 3. It's also possible that you'll get a situation where data's just missing, where it's just nothing there. And if you delete the data, you'll notice it puts in a little full stop there. That's its version of a null value. It's another way in which missing data can occur. All right, click on that. You can see now it's got 2 missing values. It's got 9 and what it calls a system missing value. That's that null value. And now the difference between the percent and valid percent slightly more a difference here between because we've got a different number of legitimate and non-legitimate values. Now, if I want to attach some value labels to these, they would kind of look like this. One would be one is clerical, I believe, yeah, and two is custodial. It's the smallest group in here. Custodial is people who look after facilities management, that type of stuff, security and cleaning and that sort of stuff. And three is manager, management. I click OK at that point. See, now it says clerical custodial manager. I could come up with 9. I could actually attach a value label here for category 9 and say that's just unknown. Because we don't know it's missing or it hasn't been determined yet or something like that. We don't know what that person is. And you can see now it just labels that as unknown, but it's still within the missing group. So it's really useful because it means that we've got a lot of missing data. It's not included in your percentaging. You also notice silly little things like it's got decimal place. That's just because of how the data was formatted in Excel. We don't really need decimal places. We don't need it to be 1.0, 2.0, so we can just get rid of those. And you can see now it's just 1, 2, 3. So there's various things we can do here. We can change the width. We need more. Sometimes you'll get a lot of fields read in. They're very squeezed together like that. That's also a property which can be changed here. This is called the column width. Same as me just changing the slider. You see this suddenly got wider again. So there's all these different properties we can attach to it. Now, one could go through this. One could actually manually go through it and start to apply value labels to it. Another approach one could take, one could use what is called SPSS syntax, because SPSS predates Windows. And you could actually put in code here, syntax, and I could say, okay, look, I'm going to run a command called variable label. It's really, really simple command. This is really plain English. Let's see, which one should I do? Minority. And I just give it a little label and say, and I think it's just something, I'll just put something like minority group, whether or not they're an ethnic minority group. I'll put ethnic minority. Ethnic minority indicator or something like that, because there's only 2 values in that. And it was one of the variables, one of the things which was recorded. You can see it's this field here, minority here. And it doesn't have any value labels attached, variable labels, sorry, attached to it. So I could put variable label minority here. You can see it's just attached that variable label to it. So that's another way in which I've got a command for value labels, got a command for missing values. I could put this all into code if I wanted. That could be very powerful if you're recording your analysis. But the third way is if you've already set the data up previously, you can actually copy the properties from one data set to another. So I could go here and say, I've got another data set here called employee, just the variables, where it's got no data and it's just got the fields set up. And it basically matches all the different properties to the field names. So it says, oh, I've got a field called employee. I've got a field called employment category as well. Do you want me to copy these properties across? And I say yes and finish it. And suddenly the whole thing's just formatted for me. And you can see that when I come back to this data set here, these labels are popping on and off. So I can see the raw code and I can see the labels. You can also see that some fields don't require labels because you don't need a label for what is your salary. It's $57,000. So you just type in 57,000. It's been formatted correctly as dollars and so forth. You can see also that these fields here I changed at the top. I can change them and alter them, saying actually that person there was a custodial worker and that person there was a clerical worker if I can remember what their codes were. Another way to read data in, another data format one might get, you can obviously it's more in Excel, you can have things like CSV files. Sometimes people have stuff in databases. So I could go and import something from a database. I've got a database here called a SQL database here, which is just full of databases that I've used over the years. I could read that data in. I've got a little one here, which is just an MS Access database, and I could go and browse for that. There's a bit of a gotcha here. People and use this. For some reason, it says the file of type it's looking for is an Excel file, but if I just change that to Access, you can see it's looking for the employee access database. If I click OK at that point and hit next, it'll take me to the available tables. There might be more than one table here, and we could join them together, but in reality, there's just one table here. This is employee again. Same data set as before. Hit finish. It reads that data in. It replaces the original data set. I'm just going to get rid of these windows I've got open. The syntax window I don't need anymore. And the output window, I'm actually going to close that down too. I don't actually need that because I'm going to start from scratch. And if I go to data again and copy data properties, and once again search for my earlier data set employee, just the variables where the data's already been formatted, I can format this in one pop, in one go. So it suddenly does that for me. And there you have our data set ready for us to analyze. So that's why formatting the data is so important. Another example of formatting the data is that when I right click on a field like this is a field which is a number field. You can see it's indicated by a ruler. It's called a scale field. It gives me appropriate statistics for that. It gives me the mean, the median, the minimum, and maximum. Whereas this field next to it is set up differently. This is set as what's called an ordinal field, a category field. If I ask for that, it gives me percentages. So how the field is formatted makes a difference. Whether it's scale, whether it's a number field, whether it's a category field, makes a difference to the sort of default statistics that it will run on it. And if it's misformatted, it can cause a problem. So for example, here if I change this one accidentally here to nominal to a category field and then asked it for descriptive statistics, it would just give me this nonsensical table because it would think it's a category field. So formatting the data is one of the first things that you kind of get your head around when you're working with SPSS. You're reading data in from SurveyMonkey. You're reading data in from Excel or CSV. You need to know how to format it in SPSS first. In fact, we've got a series of videos coming out just within the next couple of days where we're looking at, if you are working with SurveyMonkey, what the various options you have with regard to reading the data into SPSS. Okay, having done that, let's have a look at analyzing the data and manipulating the data. Next thing we're going to do, you saw me right-clicking here and doing some really simple statistical procedures. Most of the procedure that you're seeing me run there is basically the frequency table procedure. It's basically this table here. So this is appropriate for things like category fields. And I could go here and ask for like bar charts. It's just a really simple, it's just basically give me percentages. That's all. This is the most basic procedure you can run within the SPSS if you want to play around with it. I couldn't really use that procedure with these fields like current salary here. I couldn't really do that because, as you can see, it just tries to give me a percentage table of current salary. That makes no sense. I'll delete that out. But what I could do is I could say, okay, look, switch off the frequency tables and go to statistics here and give me for this procedure, for this particular field, give me the mean, the median, give me the minimum, maximum, give me some standard deviation, give me some summary statistics for that field. I could actually use more than one field here. I could current salary and people's beginning salary and click OK. And it just goes off. I forgot to switch off the bar charts. Bar chart's not appropriate for that. What I should be using for that type of field is histogram. That's the proper way for continuous data. The histogram shows me the shape of the distribution. And I can delete some of this clutter as I'm going along if I don't want to keep it. Something that's quite important is that if we want to look at the relationships between variables, a good place to start is to go to analyze and go to somewhere like a descriptive statistics crosstabs. And crosstabs is really useful when you're looking at the relationship, say, between category fields. So if I want to look at the relationship here between gender and employment category, doesn't really matter which one goes in the rows, which one goes in the columns. This is just a simple table. You can see it just produces this table here telling me How many females were clerical workers? How many were managers? How many males were clerical workers? How many were managers, etc. You can see that 0 females were custodial workers. If I click on that again, you can see I'm going back and working iteratively here. I'm going back and using this little dialog recall button here, which keeps a record of the last 12 procedures I ran. So the most recent procedure was crosstabs. When I call it up again, you can see that it's remembered the last, it's kept all the settings. It hasn't gone back to the start. And you can also see that I can actually drill down into the variables themselves and see the codes beneath them. So that's quite useful. You'll see the codes. And I can also ask it to show me either the field names, the headers, field names, or the field labels, the variable labels. It's another way to play around with it. And the dialog box is elastic. You can resize it. You can drag and drop stuff in there. If I go to cells here, I can ask instead for row percentages. And I could go and say, oh, give me a clustered bar chart at the same time. Click OK at that point. Okay, so here you can see now that the table's a little bit bigger. It's saying 95% of females, because that's the row percentage, were clerical workers compared to 60, just about 61% of males. Only 4.6% of females were managers compared to 28%, nearly 29% of males. So there's a big difference here. What happens if I wanted to compare, I don't know, gender by salary? Well, that wouldn't work for the same reason that we saw earlier on. It would produce this nonsensical table because salary is not a series of categories. It's individual values. So one of the things we could do is we could go to this really useful procedure under the transform menu. Now we're looking at manipulating the data to get the best out of it. And we could go to a procedure called visual binning. And if I pick up current salary, and I say I want to visually bin that, it scans the data. It shows me the current salary distribution as a histogram, where each of these bars represents a salary range. So the arbitrary salary range, let's say it's about $2,000 or so. And I can say, I want to create a new version of this field. I want to create one called sal band. And it calls it binned here. It's just kind of a statistical term. I'm going to change that to grouped. And now I'm going to tell it where to slice this distribution. So it's a bit like slicing a cake. And what I do is I ask it to make cut points for me. And what I generally do is I ask for equal percentiles based on scanned cases. So I say I want 3 cut points. That will break it into 25%. So that'll be group. So that'll break it into quarters. If I hit apply at that point, you can see it's found the points whereby the values whereby it's trying to slice it as evenly as it can into quarters. It can't always do it because obviously if all the data was concentrated in one corner, it'd be quite hard to slice it into quarters. But here it's doing its best. It is creating some unusual threshold points like 23,850. I think that's kind of weird. I might want to move that. I might want to round that up to 24,000. There are different ways in which I can do that. I could actually move this bar along because it's dynamic. And you can see it's actually taking account of where I'm moving it to. You see it's changing these values as I move them up and down. Because this is the first cut point, okay? So I'm actually going to change it to 24,000. So I'll just double click it and change it here to 24,000. And it moves it there. Next one's 28,500. Well, I'm going to change that. I don't really care about it being exactly quarters. I just wanted to make sure it had enough cases in each of them, in each group, to make it reasonably meaningful. We don't end up with like 5% of the cases crammed into one group. And this is 30. I'm going to change that to 37,000 instead of 36,600. And now I'm going to ask it, because it's going to create codes 1, 2, and 3 for me, I'm going to ask it to make value labels for me. And if I don't like the value labels here where it says less than or equal to, maybe people don't understand what that means. So I'll say up to 24,000. And here we have 37,000. I'm going to change that to, instead of 37,001 plus, I'm going to change that just to over 37,000. Then I click OK at that point. It tells me I'm going to create a new field for you. You okay with that? I say, yep, click OK. And my new field is created for me at the back here. Now, it's not going to be exactly 25% in each group, but if I right-click on descriptive statistics now, You see it's kind of 26, 24, 23, 24.9. It's close to 25%. Why would that be useful? Well, it means that if I go back to crosstabs here, I can replace current salary with my banded version of salary and click OK. And now I can say, look, 49% of the female employees are up to 24,000 compared to only 7.8% of the males. 27% female employees are in the 24 to 29 bracket compared to 22% of males. 15% of females in the 29 to 37 bracket compared to 30% of males. And only 7.4 all over 37,000 compared to nearly 40% of the males. You might want to run a statistical test against that to see if this is statistically significant, to use that term. And the test which is associated with crosstabs is called the chi-square test. We click OK, it runs it again. It gives us a chi-square test. It tells us the asymptotic significance, the two-sided asymptotic significance is less than 0.001. What does that mean? Well, if I double click on this, I can click and say, what's this? And it says a significance level based on an estimated asymptotic, means estimated distribution of a test statistic. Typically, a value of less than 0.05 is considered significant. This is less than 0.05, of course. In fact, it's less than 0.01. In fact, it's less than 0.001. So that would be regarded as a statistically significant relationship. We also have this bar chart that's created here. We can double click on that. And we can say, okay, well, look, I want to edit this bar chart. I want to change it. You could say, okay, I want to, there's with different things I can play around with here. I can change around the colors, etc. I could click on the bars here and move them about. Another approach is I could ask for the numbers to be applied to it. Another approach is actually to right click on them. So actually say, well, look, I'm probably not going to use this bar chart in its current state. I'm going to put it into a report, or it's going to go into a PowerPoint deck or something like that. So I could copy this Microsoft Graphics object. Let's see if this works. Sometimes a bit fussy, depending on how it's been formatted. If I right click here and click this, you can see there, it's pasted it, but it doesn't look the same. That's because it's picked up the fact that it's picked up the data behind that chart. So it's actually a Microsoft Graphics object here. And it's a chart, so I could say, okay, look, I want to change the chart type. I actually want to change it to stacked bar chart, which I can also have in SPSS. I want to change the colors to different formatting here to use these colors. And I want to change the layout so that it looks like this or like that. Maybe I'll have it like that and I'll have it like that. So it's the same chart as before. It's the same data behind it, but obviously you don't have to edit the chart within SPSS. You can edit it if you're putting it into Microsoft Office product. You can copy and paste it as a Microsoft Graphics object. So it's a useful thing to know about. Okay, what happens if I wanted to, create something that's a bit more complex than simply a crosstab here that I've been working with? I'm looking at a crosstab that we've been working with here. So, well, I could say, well, actually, I've got the tables module to work with, what's called the custom tables module. I can click on that. And the custom tables module allows me to create, as you can imagine, customized tables. So it gives me a lot of control. It's very visual. So I could pick up, for example, employment category here, and I could put it across the top. I could put current salary next to it. Maybe I've changed my mind. Maybe I'll put current employment category down along the side. Now it's a cross tab. Now I can add on minority classification on the end of that. Or maybe I'll have minority classification as a subgroup of employment category. And maybe I'll have something like age added on to the end here, showing the average age. And maybe I'll add in some totals here. So I'll put in the total here. Let's say I remove something like custodial. I'll say I'm not really interested in these guys. I'm really more interested in the difference between clerical and managers, and click apply at that point. And I don't want the counts shown. I want to change that so it actually shows me percents. Let's say I want row percents. And I want that just, instead of saying row percent, I just want to change to percent. Apply the selection. And then instead of the mean age, I want actually to show that as the median age or something like that. So I can say click here. Make sure I've got that highlighted. Summary statistics, there's mean. Do I really want the mean age or do I want something else? Well, I might have something like a median age, something like that. I could choose median, median mode. So I could add in the median as well if I want. Let's add in the median as well. Hit apply selection, click OK. And let's put total at the bottom here as well. So we've got a total at the bottom under these guys. We could even have a subtotal. We could move it so it applies at the top, so it appears at the top, so the total goes to the top rather than. Sometimes people like to do this and like to change it from the word total to base, depending on how they want it. And then click OK at that point, and it goes and creates that table for me. So, in fact, you can double click on these tables and you can say, well, actually, I've got a baseline here. I actually want to create some charts off the back of this, and right click on that and say, okay, well, create a little bar chart for me, and it just goes and creates a bar chart of those values that you've graphed for yourself. And with regard to the tables themselves, you can change the look of them, of course. You can go to format here and go to table looks. We actually create our own table looks on our website, which you can download. There's a bunch that come with SPSS. You can choose different ones that you want. I'm using Web Report Blue here. You can go for that one if you want it and say, okay, I'll have that slightly different blue format table. Change that. Or you can create your own table looks by editing them and changing the fonts and the colors in the background, and then have that set up as by default. What happens if you wanted to actually remove a group or filter out a group? Let's say here we're really interested in the difference between managers and clerical workers, or maybe we just want to take out the managers. I could go to select cases to filter data out, and I could say if select them if the employment category is less than or equal to, I can't remember the codes. Let's see what are the codes for that. Well, 1, 2, 3 is clerical custodial manager. And if I want to exclude manager, I want to say less than or equal to 2 or less than 3. Less than or equal to 2. And I could even put in another condition there, like and say, and they're aged over, I don't know, 40 or something like that. And click continue. And that would either filter out the data for me. So you can see that these cases were now filtered out. So if I right clicked on this and said descriptive statistics, you can see that managers disappeared. And if I said show me, average statistics on age, you'd see that the minimum age was 41. So we know it's working. Or alternatively, I could say, okay, I want you to actually copy this filtered data set to another window, if you like, another data manager for me, another data editor for me. So I call this non-managers over 40. Click OK at that point. It runs that, and what you'll see is that you've got this little label up here. The data set hasn't been saved, so it doesn't have a name, but it's got a little label, non-managers over 40, and they've been copied there. Meanwhile, back here, we've got our filtered data set. So I could go back and say, okay, select cases, all cases, click OK, and it says, okay, do you want me to switch off that filter? And I say yes, and we're back to looking at all the data. The non-managers over 40 is still here, of course. It actually creates a little field here indicating whether or not, in the original data set, whether or not they fell into the selected group or not. It just marks them. That's all it is, that filter field, just as a marker. We don't need it. It overwrites it every time. So, there's some things we can do there with regard to manipulating the data. We want to play around. We want to filter out groups. And we can see how we can identify statistically significant differences. What about things like the graphics and playing around with the charts, if we want to play around with the charts? Well, to do that, if I go to graphs and chart builder, the chart builder here basically allows me to build up some basic charts. So if I go for, let's say, something like I did use a stacked bar chart earlier on. I started out with this clustered bar chart. I moved it into Microsoft Office, and then I turned it into a stacked bar chart. We could do the same thing here. I could say, okay, look, I want to put employment category in the colors, and I want to put my new variable current salary grouped into the horizontal axis here. And if I go to chart appearance, you can see that there's different templates. I can change the colors. If I don't like the colors, I can change them. See I'm changing them here, making these, deep dark red or something like that, whatever I wanted. But there are different templates. There's what's called the American Psychological Association template. There's a template here called Bright, Legacy, which is the old one, Pastels. Or if you're printing it out in black and white, you can have Publication Gray or Web Report. I like Web Report. Another way to do it is to go to user specified, and you can browse and look for a chart template. Let me just see if I've got some. I might have some. Let's see if I can find some. Let's see. Chart looks. Oh no, this one here. I've got one here called Lollipop, which I use for category for ordinal variables for rating scales and stuff like that. So I could do that and say, okay, I'll use that. And just pop that on, so it makes it graded, going from deep red through the eventually through the green. You can see here's the categories here it's showing. So I can say, yeah, that's fine. I can click OK at that point. It goes and produces that. If I double click on this, I can say, actually, can you convert that so that it's scaled to 100%? So it's not just the count alongside, it actually scales it to 100%. Another way to do that. Another type of chart we can do is a scatter plot. We actually have some nice data here to work with. One of the reasons why this is a very useful data set is because it has a nice mix of fields, which everybody understands. We might want to look at, for example, the relationship between current salary and beginning salary. And we could have that gradated or change. We could change the size of it by age. We could have the color set by age as well if we wanted to. We could do that, or we could have it colored by employment category if we wanted to. So click OK at the point. So we've got 3 variables in there, and we get this type of chart coming out, as you can see. What we're seeing is that there's a strong relationship between beginning salary and current salary, as we'd expect. The higher your beginning salary, the higher your current salary. We can see that the older people, the older age groups are actually, because these are larger circles, around the bottom of that relationship. They're actually down the bottom, as are and if we look at the type of employees well, they're custodial and clerical workers. They tend to be older because the circles are larger. They're red and blue, indicating that they are custodial and clerical workers. They're in the lower beginning salary and lower current salary. And the smaller circles are actually the younger people or the managers, and they're above what, $25,000, $30,000, something like that in their beginning salary, and above 50,000 on their current salary. So there's actually a lot of information in there for us to play around with. Something to bear in mind is that at all occasions we can actually go back down through these procedures that I've been running here, like crosstabs, and I can hit paste. If I hit paste, it shows me the command that I've just run as syntax. So I could actually rerun that command as a piece of syntax. And that means that if I just delete everything in this, select all and just delete everything, I'll go right to the top. I could go back here and say, okay, there was my crosstabs. What else did I do? I did some frequency tables. I'll paste those in. What else did I do? I did some visual binning. I've already done that. I did some custom tables, I think. I paste that in. What else did I do? I did chart builder there. I'll paste that as well. Before I know it, when I come back to the syntax job, I've actually built up quite a lot of syntax. So it means I could rerun that procedure again. It just goes and does my analysis for me again on the same data set. And that, in fact, works across most procedures. Pretty much everything you do, you can turn into syntax. We have a series of videos on our website that teach people the basics of syntax, how you can build up your own syntax jobs. We also have some recorded webinars on our website, because syntax is something we talk about in other webinars, which you can go and look at if this is useful and interesting for you. But suffice to say that I could actually start from scratch here. I could go File, New, Data. And I've got I'm going to close down my old syntax window here. I'm even going to close down the output window here and just get rid of that viewer. And I'm just starting from absolute scratch, and I'll say I'm opening up a syntax job that I did earlier that gets the data as an MDB, as an access file. Then it applies what we call a dictionary to it. That means that it copies the formatting across from another file. Then it recodes age into different groups, and it does crosstab. So it's not just the salary variable that we could have used visual bander against, the visual binning against. We could have used it against lots of other continuous fields or scale fields like age. But if I run the whole thing, you'll just see it just runs the whole thing, and it just goes, reads the data, formats the data, and squirts out the results for me as a series of charts for me to play around with. So very, very, very efficient way. It's one of the reasons why SPSS is so popular. It's one of the things. And if you wanted to export the results, well, you've seen me exporting the results by copying stuff. You can see you can copy that as an Excel worksheet. You could just copy it as an image if you wanted to. You can copy it as an Excel worksheet. You can also go to File here and go to Export if you want to do the whole thing. You could export them as Excel. They actually render quite well, Excel, particularly to the tabular stuff. Put some separate cells. Or as PowerPoint, does quite well as PowerPoint too. Or as PDF. The only thing you might want to bear in mind is that it says export all objects. You might want to choose all visible objects, because actually within the viewer window here, when we look at the output here, there are hidden objects, the stuff which you can't see, and that they are represented by a closed book symbol. They're called the notes items here. You double click on these icons and it opens the book. And what it does is it shows you the syntax that was run, and it shows you when it was run, and it shows you what the active data set was. It tells you whether or not there was a filter, whether or not the data was weighted, whether or not what's a split file, what's it called, split file, how many rows were in the data set. In other words, it's a log of how that output was created. It shows you the syntax it was commanded, was run. It shows you the name of the file it was running. If it's been saved as a data set, it tells you whether or not there was a filter switched on. It gives you all the information you need to reproduce that output. So should you wish to do so. So when you come to exporting the output, you might want to say, well, export only the visible stuff, because you might not want that information exported as well. Or alternatively, I'd say quite a lot of people would just cherry pick the stuff that they're interested in, and go through this output viewer and copy and paste it as they're going along. Okay, that's our overview of SPSS. It's our little demonstration of SPSS and introduction to SPSS. I hope you found that useful. There are a bunch of additional resources on our website you should be aware of. We've got FAQs, help you find out everything. Like, for example, if you want to find out what modules you have installed, you can find out that. You've got lots of little video guides here, how-to topics and mini demos. Obviously, when you get this as a PDF, you'll be able to click on these, but there's some new stuff that's come along. We've even got an Eat Your Greens blog series that you can play around with, and there's some free online training materials for Smart Vision customers. Other people can purchase them. Okay, some questions in the question facility, in the chat facility here. Can you do a reliability check on SPSS? Yeah, there's a bunch of different reliability tests you can run, things like Chromebax Alpha. There's some new stuff that's come in. They're part of the scale. Dave, let me see if I can find them here. Let's see, scale down here. So you see reliability analysis there. There's weighted kappa. There's a bunch of different procedures here that you could do reliability. And let's see the statistics there that you could use. So yeah, there's a bunch of different reliability analyses one can do. In my data, I have 30 odd value labels all set out in a table in Excel. These will look at, is there an easy way I can add the value labels? Do I need to add them in? You need to copy and paste them across. Yeah, because you're not going to be able to use Excel as a VLOOKUP. It's a non SPSS concept. It doesn't know what that is. It's just a third-party file type. It doesn't have a native link to Excel. That being said, a smart way to do it, if it was me, is I would go on to the look up on our website the little video on syntax. Look at the bit on value labels, because there's a value labels command. You could copy and paste the value labels into syntax window, just copy and paste them as a block, and then just write value labels. You probably have to put quotes around them and maybe a number in front. So one quote blue, two quote brown, three quote red, or something like that. But it might be faster to do that. For the scatter plot, does it mean that the bigger circle for age has more people as well? No. It means that that data point there, so that individual circle, it's not aggregated. The individual circle refers to an individual person, unless of course there's more than one person within exactly the same data point, in which case they're kind of superimposed on top of one another. You can't really see them. That is an issue sometimes with scatter plots. You might be 30 people all same values. Generally speaking, that tends not to happen. The circle just means that they're older for that one. Can you get data from somewhere like Azure Cloud Storage? You should be able to get data from Azure Cloud Storage. Yeah, I mean, you can get data off the internet. And there's an odd way for SPSS to look for odd data if you find the number 9 manually. What if I don't want to look for odd data manually? Is there a way for SPSS to look for odd data? Well, it depends what you mean by odd data. Odd data, there's a thing called anomaly detection. So if you go down here to, is it validation here? Let me see if I can see this. Data validation. There's something called anomaly detection, identify duplicate, and identify unusual cases. You could say identify unusual cases. And you could say, okay, I want to look at unusual cases in employment data, that sort of stuff. Another way is you could actually physically search for a value. So that's something to bear in mind. Could you get data from Azure Cloud? Let's see. There is definitely a connection to the internet, data on the internet now. Let me see if I can find that. How can we find out what the symbols mean, like plus? Well, it depends what you're referring to there, but I mean these symbols here, these are all in the help system. So you can see here if these plus, greater than, less than, these are all standard symbols which are used across SPSS. So these are standard mathematical symbols which you use: less than, greater than, equal to, not equal to. They'll be in the help system. Help system's quite functions. It's got quite detailed and documented help system. Let me just see if I go to file. Import data, SAS data, general open. Internet data. There is something here called internet data. You should be able to find a ways and a means to do that by connecting to internet data. Yeah, I think so. Okay. Yeah. So links to syntax resources are on the data set, and other resources are there as well. Can you port data from Qualtrics? Yeah, well, Qualtrics will export data in different formats. So, Qualtrics will. I don't know if Qualtrics exports data as SPSS files, but it'll probably export it as a CSV file at least. I've certainly analyzed Qualtrics data in SPSS on many occasions. I can't remember if it came out as a Excel file or as a CSV file, but it might well be that Qualtrics exports as SPSS SAV files. I know that in SurveyMonkey you can export an SPSS SAV file, but it's a thing you have to pay. You have to have the right license. In other words, they kind of make you pay a bit more if you want to have that luxury. And it's something which we cover in the forthcoming series of videos that we have on that. So it does CSV and Excel. Okay, that's fine. So yeah. But ideally, if it does export as SAV, then it would be a lot easier. SAV files are SPSS native data files, so they have. I've got employee backup here. You can see they've already got all of this formatting and labels and stuff attached to it. Oh. Okay, with that in mind, there are other resources, as I say. There are free online training materials to SBS to Smart Vision customers. Other people can actually download them or purchase them if they so wish. We do have a full range of consulting services that we work with. So these are, small bite-sized consultancy jobs where we're doing like a day or even, a couple of days, maybe a week or longer to work alongside you with your own data. And you can, if you're purchasing analytical software such as SPSS, you can often purchase it. You can purchase it directly from us. You can even buy it online. Bear in mind that that will give you access to all of our training catalog. And it'll also give you access to our own technical support services. We're quite a small company, but we're obviously experts in this particular area. That being said, we do offer no strings attached technical business advice relating to all things analytical, whether or not you're a customer of ours or not. And the best thing to do is just reach out and ask us, and we'll try our best to help you. In the next web session, we're going to be taking a deep dive into significance testing. So the whole business of statistical significance. What does that mean? We're going to be looking at chi-square. We're going to be looking at correlations. We're going to be looking at confidence intervals. It's going to be quite compact, quite a lot of stuff involved in it. But if you are doing any sorts of statistical significance testing and you're not 100% clear on what the context is around that, I would recommend it because we're trying to cut through a lot of the misinformation that's out there on the web that we encounter all the time. And we want to keep people, pretty straight and well informed when it comes to interpreting statistical tests. Okay. In the meantime, thanks very much. We look forward to you logging in again in the near future. Thank you. Bye-bye.